derive y minus y1 equals m open bracket x minus x1 close bracket. First thing we need to note is that x, y is a coordinate of a point. Every point has a coordinate. A two-dimensional graph has two instances of coordinates. For a graph, we always have the y-axis, and this is the y-axis, crossing the x-axis at x equal to 0. So that's why the y-axis equation is x equals to 0. We have the x-axis crossing the y-axis at y equal to 0. And that's why the equation of the x-axis is y equal to 0. Now I'm going to pick 2 points, and I'm going to use subscripts to describe those 2 points. I've picked my first point and my second point. Now I'm going to label the first point, point 1, and second point, point 2. Point 1 will have x subscript 1, comma, y subscript 1. That's the coordinate of point 1, because coordinate has x and y. X first alphabetically and then y. Point number 2 is x subscript 2 and y subscript 2. The next thing I've done is to join that point to here and join that point to here. I need to find this height, I need to find that length. So my next move is to find this height and find that length. So this height is going to be y2, this is y2 minus y1. So that will be y1 and y2. So this is y2 subscript there and y1. Okay, this point here from there to there is x2, that's x2, because that's the x-axis here, x2 minus x1. So if I draw that to there, that's x1, and that goes up to there, and that's x2. I'm trying to find the slope of this line. In architecture or building engineering, they call it pitch, the pitch of that angle. The pitch is the angle of that slope. So I'm trying to find the slope here, and the slope is also called gradient, and the gradient, we sometimes coined it as m. So we now know that the gradient is called m. M can also be called tan theta. This angle is also theta. And that angle theta is opposite here. And the adjacent is going to be the x2 minus x1. So that's divided by, that's opposite divided by the adjacent. And the adjacent is x2 minus x1. So the slope here, or the angle, the pitch angle is, well, tan of that is tan theta, and that tan theta is called m. M is the slope, gradient, and this is opposite here over adjacent, and that equals y2 minus y1 over x2 minus x1. So a good thing to remember that the slope is also called tan theta. So now it's good to know that m, we call it m in this case, or sometimes in linear equation this is actually a. So we call it m now, where it is y2 minus y1 over x2 minus x1 between 2 points. So the slope can be found between 2 points, 2 coordinates in a straight line, and bear in mind that's also tangent of theta, and that is the gradient of the line. Now I'm going to pick a point here, and I'm going to call that point x and y, and I'm going to trace that point here. That's going to be y, and I'm going to trace that point down here, and that's going to be x. You can see x is greater than y1, but than x1. You can see that y is greater than y1. So now I'm going to write my gradient between these 2 points because they all have the same gradient. So my gradient will be m equals y minus y1 over x minus x1. So I'm going to make y minus y1 the subject. So I'm going to say, well, multiply both sides by x minus x1. Then I get m into bracket x minus x1 will be equal to y minus y1. Therefore, we're going to have y minus y1 equals m into bracket x minus x1. So now we've derived the first equation of coordinate geometry. The first coordinate geometry equation is y minus y1 equals m into bracket x minus x1. So to find the coordinate geometry equation of a straight line, you only need, in this case, you need m and one coordinate, x1, y1.